It's not just like that. All right, you need to be on page 25. And we have 3 learning targets for this section. We're going to define distance. We're going to use the distance formula, which will look a lot like algebra. And we're going to construct a segment bisector. So let's define distance. The distance between 2 points is the length of the segment with those points as its end points. That's the definition that will show up on the quiz in some way. The distance between 2 points is the length of the segment with those points as its end points. So in other words, finding the distance between 2 points is the exact same thing as finding the length of the segment between those 2 points. Okay? So no matter which, the directions might say either one. The directions might say find the distance between A and B, or they might say find the length of segment AB. They're asking you the same question. Okay? The distance between A and B is the same thing as the length of segment AB. So whichever way they ask it, they're asking you the same thing. All right, so there's our first learning target knocked out already. Define distance. We did. Next, we're going to use the distance formula. Well, here's the distance formula. In a coordinate plane, a point will have an x-coordinate and a y-coordinate. Okay? Now, look at the little drawing here before you look at the formula. Pick one of your points to be point 1, and you call its coordinates x1, y1. Now, technically, that's x sub 1, y sub 1. Those little 1s are subscripts. They do not have any numerical value. They're not exponents. It's not times 1 or plus. It's a subscript. It's just a way to number points. Okay? The other point, and it doesn't matter which one's which. The other point you call your second point, and its coordinates then are x2, y2. Okay? If we had 57 points, the coordinates of that 57th point would be x57, y57. They're subscripts. They do not have any numerical value. They're just so you can count your points and keep them separate from each other. Okay? You with me on the notation there? Now, the distance formula is this, and I'm going to write it a little bit differently. I'm just going to say d for distance equals the square root of parentheses x2, so that's the x-coordinate from the second point, minus x1, that's the x-coordinate from the first point. Close your parentheses and square that quantity, plus, open a new parentheses, y2, that's the y-coordinate from the second point, minus y1, that's the y-coordinate from the first point. Close the quantity, squared. So my formula is the same as the books. I just wrote a D for distance instead of PQ for the length of PQ. But remember, the distance between 2 points is the same thing as the length of the segment between those 2 points. So this covers it. Everybody got it? Okay. Now, let's see. No, I should have copied that already. Hang on just a second. I'm going to copy that. Put it. Right there. Oops. All right. So now that we know what the distance formula is, we're going to use it. So this is from your assignment on page 30. Let's do these 4 problems together. Write them down. Okay, we have a little word problem here. Time capsule. Graduating classes have buried time capsules on the campus of East High School for over 20 years. The points on the diagram show the position of 3 time capsules. Find the distance between each pair of time capsules. And then they tell us the coordinates of each one. And you don't have to draw the figure on your paper, but I'm going to label the figure here. A has coordinates 4, 9. B has coordinates 2, -3. And then if I look down at number 4, I see that C has coordinates 9, 0. So I'm going to try to find the distance between each pair of points. For number 3, it'll be the distance between A and B. For number 4, between A and C. And for number 5, between B and C. So, for number 3, A has coordinates 4, 9. B has coordinates 2, -3. Now, in my formula, I wrote a D for distance. Now that I'm working a specific problem, they're wanting to find the distance between A and B. I'll just go ahead, I'll call it the length of AB. Equals. And now, it's a substitution problem, okay? The first letter in my formula is x2. x2 means the x-coordinate from the second point. X means x-coordinate, the 2 means from the second point. So, that's the x-coordinate from the second point, isn't it? So 2 minus x1, x-coordinate from the first point. That's a 4. Close the parentheses, square it, plus parentheses. Looking at my formula again. What's next? Yep. y2 means the y-coordinate. Second point, or from the second point, -3, minus what? 9, because y1 is the y-coordinate from the first point. Everybody with me on the substitution? All right, now it's arithmetic. All right, so inside the first parentheses, because we're following our order of operations. What's 2 minus 4? -2. Inside the second parentheses, because we're following the order of operations. What's -3 minus 9? -12. Now, following the order of operations, exponents. What's -2 squared? It's +4, because to square something means to multiply it by itself. So -2 times -2 is +4 plus, and what do you get when you square -12? 144. Now, you don't know this, but this square root sign is the same thing as a big parentheses. It's a big, huge grouping symbol. So we keep working inside the grouping symbol. Don't try to take the square root of 4 and the square root of 144. No. Work inside that grouping symbol. So what's 4 plus 144? So that's where we're going to leave our answer. Okay? There's something called simplest radical form, which I'm not going to teach you, at least not yet, probably not at all. And we could turn it into a decimal, but, there's no need to. So our final answer is the length of AB, or the distance between A and B, equals the square root of 148. Now, that might bother you a little bit because you probably don't have a very good intuitive feel for how big the square root of 148 is. But there's actually a fairly simple way to get, without using a calculator, a rough estimate. Do you know what the square root of 100 is? It's 10. Do you know what the square root of 121 is? It's 11. Do you know what the square root of 144 is? It's 12. So won't this be just a little bit bigger than 12? 12.1, 2, 3 at the most? Probably 12.2, maybe 1. All right, a rough estimate. So that's about how big it is. It's a little more than 12. Okay? We okay with 3? Let's do 4. For number 4, A still has coordinates 4, 9. B, nope, it's not B this time. It's C has coordinates 9, 0. So we're finding the distance between A and C, or the length of AC. Go ahead and fill in what you think goes when you substitute. Did you get what I got so far? Okay. Remember, x2 means the x-coordinate from the second point. x1 means the x-coordinate from the first point. y2, y-coordinate of the second point. y1, y-coordinate of the first point. So usually the hardest part of these is the substitution. So if you are doing the substitution right, we're in good shape. We good on that? All right. Now, make sure you work inside the parentheses first. 9 minus 4 is 5. 0 minus 9 is negative 9. Now I've got to square those. So I'll get 25 plus 81. So I get, when I add 25 and 81, I get the square root of 106. So the length of AC is the square root of 106. About how big is that? A little over 10. A little over 10. We good? All right. Number 5. Number 5. B has coordinates 2, negative 3. C has coordinates 9, 0. So the distance between B and C will be the square root of x2, that'll be 9, minus x1, that'll be 2, quantity squared, plus y2, that'll be 0, minus y1, that'll be negative 3, quantity squared. Underneath our square root sign, in the first parentheses, we get 7. Then we got to square it. What do we get in the second parentheses? 3. Because minus a negative is the same thing as plus a positive, isn't it? Minus negative 3 is the same thing as plus 3. So 0 plus 3 is 3. What's 7 squared? What's 3 squared? What's 49 plus 9? 58. So the distance between B and C is the square root of 58, or the length of segment BC is the square root of 58. About how big is the square root of 58? Yeah, it's about halfway between 7 and 8, isn't it? Because the square root of 49 is 7, square root of 64 is 8, so somewhere pretty close to the middle between there. All right. Can you use the distance formula? Last question in this little group. Which 2 time capsules are the closest to each other? Which are the farthest apart? Well, that's an easy question. Which 2 are the closest? Which distance is the smallest? I'll ask it again. Which distance is the smallest? BC, square root of 58, right? That's the smallest number. So B and C are closest. And then which are the farthest? A and B farthest apart. Have you ever done distance formula before? Some of you look pretty natural at it, so I thought maybe you had. Some of you are going yes, and some of you are going no, so probably yes then. All right. So far, so good? All right, so we've knocked out 2 of our learning targets. We got 1 to go. Before we can construct a segment bisector, we need to know what one is. And to know what a segment bisector is, you have to know what a midpoint is. And a midpoint is just what you would think it is. Just stop looking at the screen. If I said, what do you think a midpoint of a segment is? You would say, in the middle. It's the middle point. That's exactly what it is. The midpoint of a segment is the point halfway between the endpoints of the segment. So it truly is the middle point of the segment. And we can find the coordinates of the midpoint by finding averages. Okay? If I just give you 2 numbers, like let's say 8 and 10, and I said, okay, on a number line, what number's halfway between 8 and 10? You'd say 9. Now, you know a number line well enough, and you know numbers well enough that you kind of know that without doing any figuring. But what you're finding, when you're finding the number that's halfway between 2 other numbers, you're finding the average of those 2 numbers. Okay? And how do you find the average of 2 numbers? You add them together and divide by 2. Just like if you were trying to find the average of 15 things, you'd add 15 things together and divide. All right? Not by 2. That would be by the number of them. Okay? So, all we got to do to find the coordinates of the midpoint is to find the average of each of the coordinates, each of the sets of coordinates. So, the x-coordinate of the midpoint is just the average of the x-coordinates of the endpoints. The y-coordinate of the midpoint is the average of the y-coordinates of the endpoints. Now, how do I find the average of the x-coordinates? I add them together and divide by 2. How do I find the average of the y-coordinates? I add them together and divide by 2. Okay? So, that's how come that's your midpoint formula. The coordinates of the midpoint are x1 plus x2 divided by 2 and y1 plus y2 divided by 2. And then once we simplify that, that'll be the coordinates of the middle. Let's try a couple more problems. Number 9, back on page 30. Find the coordinates of the midpoint of a segment with the given endpoints. Let me copy this. All right, so there's our midpoint formula. So, the midpoint is going to be, all right, x1, so that'll be the x-coordinate of the first point. So what's the x-coordinate of the first point? 5 plus x2. What's the x-coordinate of the second point? 3 divided by 2. The y-coordinate is y1. What's the y-coordinate of the first point? -3 plus y2. What's the y-coordinate of the second point? -8. All right, so let's see what we get. 5 plus 3 is 8. That'll be easy. -3 plus -8 is -11. 8 divided by 2, 4. Now, what version do I want for the answer to this? Because it's not an even number, right? It's not a whole number. All right, it's got to be negative. And as far as I'm concerned, just leave it as an improper fraction. -11/2 is a perfectly fine answer. If you don't like that, you can change it to a decimal. As a decimal, it'd be -5.5. Or you can write it as a mixed number. As a mixed number, it would be -5.5. But improper fractions work just fine, so just leave it as an improper fraction. Okay? I'm not going to count it wrong if you put it one of the other ways. And the book the book has -5.5. And that's fine. I'll count that right too. But improper fractions are good. They're good math. So leave it that way. It's fine. M for midpoint. Okay? Which works really well until they confuse you, like on number 10. And M is one of your end points. So I can't call the midpoint M this time, can I? So what do I call it? I just make something up. What do you want to call it? I'm not going to call it 0. I'm not going to call it M. Give me a letter.
P.
P. We're calling it P. So P is the midpoint this time. All right. To get the X coordinate, what two numbers do I add together? 7 plus 4, then I got to divide them by 2. To get the Y coordinate, what two numbers do I add together? 1 plus -1, then I got to divide by 2. 7 plus 4, so I'll get 11 halves. And 1 plus -1, and what's 0 divided by any other number? So I can be done right then, can't I? And speaking of that, could I probably have not written that step down and been just fine? Yeah, now that you know what you're doing. First time I wanted to write it down. Now that you know what you're doing, I think you can probably go right from there to there, don't you? If you want to, you can. If you want to write it down, that's fine too. Looking back at the distance formula, if you've done a few, could you probably go from there to there? Know that in the parentheses I get a -2, and then when I square it I get a 4. That may take a little more work to be able to leave that out. And I'm not saying you have to leave it out. You have to think it, don't you? And if you think it, you might as well write it down. But also know that sometimes, especially like in calculus, when you guys get there, when we have page-long problems, sometimes you make a mistake just because you write something down wrong. And so I encourage them to do some things in their head, because they're just as likely to mess it up writing it down when you have a page full of math as you are to make a mistake in your head. So that's a balance you've got to figure out for yourself. Where are you most likely to mess it up? In your head or writing it down? Then do what works best. Okay? That I do want to see work though. I mean, you could leave that out, but I want to see the rest of it. All right? And let's see. So we did 9 and 10. All right, on this one, this is a little different. It says find the coordinates of G if F is the midpoint of GJ. I hate it when they put G and J together because I have a hard time saying it. F is the midpoint of segment GJ, and J has coordinates 6, -2. Okay, I'm confused. Here's what's going on. This is our midpoint. So I'm going to call it M. J is one of our endpoints. They want us to find the coordinates of the other endpoint. All right? Now, I'm going to write down our midpoint formula again. And what I'm going to do now is, since this is the x-coordinate of the midpoint, isn't it? I'm going to write that as a separate equation. Just watch for now. You can write it down in a minute. I'm going to write x of the midpoint equals x1 plus x2 divided by 2. And then this equals the y-coordinate of the midpoint. So I'm going to write y of the midpoint equals y1 plus y2 divided by 2. Now, here's where I'm going with this. I didn't want to just use the formula because I already know the coordinates of the midpoint. So I don't need, since I already know the coordinates of the midpoint, I'm not going to use the midpoint formula to find the coordinates of the midpoint. But to get the other end point, I don't have a formula. The book doesn't give us one. I didn't give you one. So didn't I just sort of come up with a different formula? Okay. Now, substitute in what you know. Let's look at the x-coordinate. The x-coordinate of the midpoint is 1. So this xm over here, I can replace with a 1. Equals x1. That'll be the x-coordinate of the point we know. So what can I replace x1 with? I can solve that. I only have one unknown. You ought to be able to solve any equation in the world as long as it only has one unknown and is solvable. Not everything has a solution, sorry. Okay, you with me? Kind of iffy on this? Makes you a little uncomfortable? It's supposed to. All right, but we can solve this though, right? I'm going to clear fractions like I did in the problem earlier today. I'll multiply both sides by 2. On the left side, 2 times 1 is 2. On the right side, 2 divided by 2 is a 1. So those divide out. And I have a denominator of 1 now. Does the denominator of 1 do anything? So I get 6 plus x2. Can't I now just subtract 6 from both sides and get x2? So what's 2 minus 6? So negative 4 equals x2. So now I know the x-coordinate of the other end point. I'm going to do the exact same thing to find the y-coordinate of the other end point. So take time now to write down everything I've got up here and get caught up with me. Good. I was hoping y'all be confused. I'm kidding when I say things like that. All right? Come on, hang with me. Get written down what I have written down. 3.5 is the y-coordinate of the midpoint. What replaces y1? Yeah, some of you've got it. Yes. Right here. They told me the midpoint, the x-coordinate of the midpoint. It's not a different formula. I'm manipulating the formula they gave us. Why don't I do what? I multiplied 2 times 3.5 to get 7. 2 divided by 2 is 1. Why would I multiply negative 2? Because there's a plus sign. You talking about this negative 2? It's I divided them out. We're having algebra issues. This isn't good. If I've got a plus b divided by 2, and I multiply it by 2, shouldn't I just have a plus b? That's what's going on. Does that help? All right, so I know it's weird. I know it's a little uncomfortable. You with me? Okay. What have we found then? We found what they said the name of the other endpoint was, G. We found that the x-coordinate of G is -4, and the y-coordinate of G is 9. Mm-hmm. It'd be a little, who's asking me? Yeah, it'd be a little, it's a little more involved solving it because it's a 3a instead of just an x, but yeah, same idea. Mm-hmm. It's just a little more involved solving it. Mm-hmm. Okay, let's see. All right, we're going to have to change plans a little bit. Your assignment for today will be page 30. Do 3 through 6, 9 through 12. You should find most of that fairly simple. 19 through 30. 39 through 49. We'll stop there. All right, so get 12 and then the rest of it.